Hi my friends, today we model this part called the support head, which is medium complexity. You'll see what happens when we model it. It has a cylindrical end and it continues with a curved tube. Inside is a wall. Let me show you the situation here. I use the plane, this plane, and you see what is inside. Yes, very interesting. Let's see how can we model this part. The drawing is here. You see the cylindrical part or feature is 26 with a length of 65 at 40 millimeters distance from the bottom face. We'll start by selecting this plane in respect of this one. Let's start. The end of the cylindrical part is here, and the other end is this 46. You see, circular face, this one. There are some holes or orifices. One is up, this one. 3 are here. They are elliptical, and a circle which is placed here. You see, this hole is circular, and this other 3 holes are elliptical. Good. We start with a sketch as usual, standard millimeter IPT. The sketch is placed on this plane and it consists in a circle. 26 is the diameter. It is placed on the same vertical with the center point at a distance from the circle to the point of 40 millimeters, as I said before. Good. Then we apply extrude on 65 millimeters for the cylindrical feature. We continue with another 2D sketch in the plane, bottom plane, which is this one, by drawing a circle of 46 as in the drawing, 46 at a distance of 1, 2, 3. Yes, 1, 2, 3 is the distance, but let me apply the placement of the circle on the same vertical with the center point. Here is the center point placed on the bottom. Here, this is. And the distance between the circle and that point of 1, 2, 3. Very good. Finished sketch. Now we apply selection to the face and automatically we have a circle here. Why? Because I intend to create a spline between these 2 points in the plane, in this plane, YZ. F5 to have the same view. Then I project this point in the new plane where the sketch is. I need to draw 2 small lines, one vertical, you see 0 degrees, and another one horizontal, and you see 90 degrees. Both are construction lines. Then I go to spline interpolation. From this point, when you see yellow, you are on the entity, but when you see green, you are at an end of that entity or the center of circle. Click here and green here. Okay, now I apply tangency between these 2 and tangency between these 2. Finished sketch. What tool we use to connect this circle with this circle? You have 3 seconds to answer. Professor, this is loft. Yes, my friends, loft is. I select the circle or the face because I want to create a solid feature, the other circle, and I want to have a spinal curve, which is this one, and this is not all I want because I want to apply conditions. The first must be at 90 degrees and tangent, you see 1 here. The value of weight is from 0 to 1. I apply 1 because I want to have tangent connection between the two features. 90 degrees. This is 90 degrees. No, this is. Okay. And we have a nice volume. We go further by creating a plane based on this plane and tangent to the upper generator of the cylinder, and we create a new sketch. What sketch? This is the zone I'm interested to place with that wall. Dimensions are 84, radius 4, 2 millimeters the thickness, and 60 degrees the angle. Okay, I turn this even if I change the position of z-axis, and I start by drawing a line, keeping pressed the left button of the mouse and continuing with an arc tangent to the line. I'll mention this all the time. The last line is also tangent if you select the proper position. Okay, the distance 84. The vertical, this is vertical placement of this point, this is vertical, is fulfilled. Equal, I want that lines to be equal, and I want them to be symmetrical. How do you make this symmetry? You select the symmetry tool, you select the first and the second line to be symmetrical, and then the axis of symmetry, which is z-axis. Nice, very nice. I make this construction line. I don't want to participate there, and keeping in mind that this dimension is 26, excuse me, I place here that value, or I select fx to find the value. This is 26, this is d0. I place here the dimension of d0, d0. Now, because of this small distance, I'm sure that even if you change the diameter of the part, you will have always a correspondent dimension here. Next is an offset of 2 millimeters and ending with ends. If you see yellow is not good, if you see green is good. Be careful. I select the end point, or I select a point on the line. This is yellow and this is green. Good. Escape. 2 dimensions needed. Yes, of course. Angle and radius. Dimension. Angle is 60 degrees. Internal or external, no problem. 60 and the external radius is 4 millimeter. Now we have a fully constrained sketch. Finish sketch. What is the depth or the height of the wall? It is exactly the diameter of this cylindrical feature. We see this here. You see, this wall comes from up, and D0 is this dimension. We make an extrusion with the height of D0. Extrude this the other direction, and we don't add this new feature to the former object, but we select a new solid. We want to create a new solid now. What is the height? D0. Okay. You can change the name D0 as you want, but only one word: cylinder dia, cylindrical diameter. Yes? Okay. Done. And now if I apply double click here, I see cylinder diameter, the height of this extrusion. Visibility, not interesting. And now we have two solids, my friends. Yes? Very interesting. As you can see in the drawing, there is another wall, horizontal, along this section in the cylinder. 2 millimeters is its dimension, its thickness, 2, 2, and 2. Always the thickness is 2 millimeters. Good. What we create here on this plane, F7 to see inside, we draw an external line between these points and a mid one. If I place here equal, I obtain the symmetry. Right? Right. This angle I want to be the same with the other one. So I go back to Fx. The angle of 60 degrees is somewhere. Look, this is. The name is my angle. My favorite angle. As you want. So that when I apply here the dimension, I go to my favorite parameter. This is my favorite, my angle. Good. Fully constrained. Finish sketch. And now extrusion. We don't include this. Only this is enough. And the thickness is 2. we can define the thickness with 2 and to use it as a new symbol. Wow, look here, what a construction. There are, oh, my mistake, this. I wanted to add this wall to this, but I can use combine by selecting no matter which is the first and the second to put this together. Okay, now we have two solids. Yes. Why do I what I do? Because I want to create an intersection body here, but that intersection body to be a new object and to keep this volume, not to lose. To obtain this, we go to combine. I want you to observe that this is a singular object, base body, and this is plural objects, tool bodies, so I can select only one solid here and many solids here. Base body for us is this one. We want to keep tool bodies. The second is the tool bodies. For us, the tool bodies is tool body, this one. And what do we want here? We want to join them, or not? No, my friends, we want to cut, to make an intersection between the two volumes, and we want to keep this and not to obtain only the intersection. In the first moment you see only the intersection body, but you can activate with visibility this second or first solid to see both of them. If you want, you can make not visible the first one or the second one. Yes. Be careful to select firstly the small object and the second the tool body. Okay. Now we take a look at the drawing and we see that the thickness of the main body is 2. Good. We apply shell and we select these two faces because we don't apply lids. Yes, we want to have a hollow internal volume. This intersection does not participate here. This is why I wanted to have two objects and not one. And the thickness is 2. Okay. Now we combine them. It's time to combine. But first let me hide this sketch. Good. Combine, I said. Combine. I select the base or the intersection, no matter about the order, and you will see what happens. You will see that we have only one volume, yes, as we wanted. Good. We continue with this hole, which is a circular or cylindrical hole with dimensions here 20 millimeters with 17 the distance. We need plane to start the sketch, and I select axis, this axis for the plane. I select axis and I select this plane. You see 90 is okay. Good. I create a sketch here, F7 to see inside. I place a circle of 20 placed on the vertical. Oh, this is horizontal. I suppose you can see a very tiny fine line in dots, because this is vertical, this horizontal is a vertical. Finish sketch. The sketch is not completed. You don't see here the mark of full constraint. Yes, there is a point here. Look to this one. It has a point. Double click here and we see that I forgot the distance, which must be 17, and now we have a fully constrained sketch. Extrude, cut through all, okay. This hole is tangent to this cylinder. I hide the plane visibility, I hide the axis visibility. Good. Now I want to make here the orifice, elliptical orifice, which is placed at 112, an ellipse 33 on 22. You remember? Good. I want to mention that the ellipse is cutting this. If I go with it through the part. I want to mention that the ellipse is cutting this. If I go with it through the part. This is why I select this face for the new sketch. This face. F7 to see to the face, and I create that ellipse. Excuse me, not circle but ellipse. Major axis, minor axis, dimensions 33 divided by 2. Don't make calculus by heart because there are many risks. 11 divided by 2, not 11, 22 divided by 2. I was thinking at the half. The horizontal, which is vertical again. Oh my God, always that situation. The problem is that I must work in this position to have vertical as a vertical. Yes? Problem. This is a minor fact. And the distance of 112. From where? From where? From the point to the point. 112. Finish sketch. You see what is here. And now extrude this with cut through all the part, but up, not down. Okay. The last features are these three orifices. These three dimensions: 18, 10 for the ellipse, 17 again, like here, and three of them well, I have to place a plane about that axis I used before when I created this hole. This is this plane, and the axis visibility and this plane. With angle of 45. This is 90. And this is 45. Okay. In this plane, we create a sketch, F7, with an ellipse, vertical one, major axis, minor axis, dimensions are 18 divided by 2, and 10 divided by 2. (17) from the center point, from here to the center is 17. I project the axis coincident this projection and this point. Good. Finish sketch. And extrude this on this direction, the other direction, on a distance of 46. I'm sure that this will be outside because 46 is the diameter. Okay. The plane visibility, the axis visibility, and I have a new hole. Now I don't make this visible because I apply circular pattern of the last feature, which is this one, and the axis, which is this one. I want to cover 90 degrees with 3 instances in this direction, you see, like this. But it is good. Then I hide the axis and I add these fillets to each fillet of 2. 2 is by default. Okay. 1, 2, 3. Okay. Our last and traditional operation is to see what is the volume of the part. Update, and we select all this. Copy, close, double click, and paste. Almost identical. Yes, not important. We have a loft there, we have intersections, so this is a minor difference. Cancel. That's all for today. Thanks for watching. Bye bye.